Welcome to today's math lesson on distinguishing or telling the difference between proportional and non-proportional situations from tables, graphs, and equations. Our do now reads, Keyshawn bought 5 pears at a cost of $9.25. Is this relationship proportional or non-proportional? So from here, I'm going to find my rate of change, which is always the change in y over the change in x. So this triangle right here is a Greek symbol that we use to represent change of. It's the delta symbol. And so we have to first figure out what is our y value and what is our x value in terms of these two numbers. So we have to figure out, does our number of pairs depend on the cost, or does the cost depend on the number of pairs? So the cost is going to depend on the number of pairs. So as our dependent variable, 925 is our y value, and 5 pairs is going to be our x value. From here, I have 925 on top and 5 on bottom. So when I divide 925 divided by 5, I get 185. And then to write my equation, I know that it has to be in the form y is equal to k times x. So I'm going to replace a k with the number. So I have y is equal to 1.85 times x. And now we have to fill in the table, or fill out the table. So we have different x values filled out, so 0, 2, 4, 6, 8, and 10. And our process is going to be, we're going to multiply 1.85 by each of these x values. So I have 1.85 times 0, and that's going to be 0. Then I have 1.85 times 2, and that is going to be 3.7. Then I have 1.85 times 4, and that is going to be 7.4. I know I'm writing over the boxes, but the table is quite small. Then when x is 6, I'm multiplying 1.85 times 6. And that is going to be 11.1. And then when x is 8, I'm multiplying 1.85 times 8. And that is 14.8. And lastly, when x is 10, I'm multiplying 1.85 times 10. And that is 18.5. And from here, I have to label our graph. So I know that this is going to be our x-axis. And then this right here is going to be our y-axis. And so our range in x values are from 0 to 10. And so since there's 15 spaces, I'm going to say that each box represents 1. So if this is 0, this is going to be 1, this is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I'm going to stop right there. And then our range and our y values are from 0 to 18.5. And so again, there's 15 squares or 15 boxes. So I can have each box represent 2. I can have each box represent 3. I can have each box represent 5. I'm going to say that each box is going to represent 2. So if this is 0, this is going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And then I have to graph the different points. So our first point is 0, 0, so that's at the origin right here. Our second point is 2, 3.7. So starting at the origin, I'm moving over to the value of 2 and then up to the value of 3.7. Since I'm counting by twos, 2, 4, I know that 3.7 is a little bit underneath 4. Then we have 4, 7.4. So starting at the origin, I'm moving to the right the value of 4 and up to the value of 7.4. So 0, 2, 4, 6, and this is 8, so 7.4 has to be in between. Then our next point is 6, 11.1. So starting at the origin, moving over to the right, the value of 6, and moving up the value of 11.1. So 2, 4, 6, 8, 10. That's 12, so 11.1 should be a little bit in between. Then we have our 0.8, 14.8. So starting at the origin, I'm moving over to the right, the value of 8, and up the value of 14.8. So then we have 0, 2, 4, 6, 8, 10, 12, 14, 14, and then 16. So 15 is in between, and 14.8 is close to 15. Then our last point is 10, 18.5. So starting at the origin, I'm moving over to the right the value of 10 and moving up the value of 18.5. So 2, 4, 6, 8, 10, 12, 14, 16, 18, and then 19 is right there. So 18.5 should be around there. And then of course I have to draw a line to connect the dots. And the last thing is to identify whether this is a proportional or non-proportional equation. And since our equation is y is equal to 1.85 times x, that's going to be a proportional relationship because it's in the form y is equal to k times x. Our TEK for today is 8.5F. Our lesson target is that scholars will distinguish between proportional and non-proportional situations using tables, graphs, and equations in the form of y is equal to k times x or y is equal to mx plus b. Then our DOL is given 4 problems. Scholars will distinguish between proportional and non-proportional situations, and it should say with 100% accuracy. So some anchor charts to help us with today's lesson. The first one is non-proportional relationships. The second one is proportional relationships. So the equation for non-proportional relationships is y is equal to mx plus b. The b represents the y-intercept. The y-intercept is 0 and whatever that number is, whether it's positive or negative. And the y-intercept in terms of like a real-world situation or a word problem is going to be the starting point or the starting fee. For proportional relationships, the equation is always in the form y is equal to k times x, with k representing the constant of proportionality. Both the k and the m represents the rate of change, so our change in y over our change in x. And then for tables, we use the same process. We use the equation and we plug in the different x values into the equation to get our y values. The graphs are similar in that they're both straight lines, except in non-proportional relationships, the y-intercept is where the line will pass through the y-axis. And so for proportional relationships, it's always going to go through the origin or 0, 0. We had an activity where students had to categorize the following words and equations into this Venn diagram. Then we have a graphic organizer. That's another picture to show the differences between proportional and non-proportional relationships. This first I do is determine whether the graph represents a proportional or non-proportional relationship. And we have to write a linear equation to represent the relationship. So starting off the bat, just looking at the graph, I see that it has a y-intercept. So it can't be a proportional linear equation. It has to be non-proportional. So I know that I have to write an equation in the form of y is equal to mx plus b. So this right here is our b or our y-intercept, and it's at positive 6. Since it's at positive 6, I know that I'm adding 6. And then I have to find our m, which is our rate of change, or our change in y over our change in x. So I have to choose another point to move up and then to the right. So this is a good point, but this is also a good point right here. I could have chosen this point, this point, this point, this point, this point, this point, or this point. And I have to find what is the value that I moved up. So if this right here is 6 and this is 12, I moved up 6 because I'm doing 12 minus 6, and that's 6. I'm going to change colors since that was kind of hard to see. So our change in y is 6 over our change in x. We're moving from here to here. So if this is 0 and this is 6, our change in x, 6 minus 0 is 6. And lastly, we have to divide. 6 divided by 6 is 1. So we always write our slope or our unit rate of change, in front of our x. So our equation is going to be 1x plus 6 is equal to y. And I can use this graph to distinguish between proportional and non-proportional relationships because, as was already mentioned in the previous slides, lines that have a y-intercept are non-proportional. Lines that go through the origin are proportional. This next I do problem reads, determine whether the equations represent a proportional or non-proportional relationship. We have y is equal to 3x squared plus 2. And this is not an equation that we've seen before, so we know that it's neither proportional or non-proportional. Then we have y is equal to 3x plus 2. We can identify that since it has a y-intercept, this is going to be a non-proportional relationship. And then to answer the questions at the bottom, how do I know if the equation represents a linear relationship? Proportional and non-proportional relationships are linear relationships because when we graph them, this would be a proportional relationship because it goes through the origin and it's a straight line. And this would be a non-proportional relationship because it has a y-intercept, but it's a straight line. So both proportional and non-proportional relationships, whether they're in the form of y is equal to k times x or y is equal to mx plus b, are linear. And then, of course, to distinguish between proportional and non-proportional equations have a y-intercept. So you're adding or subtracting a number behind whatever the unit rate, the constant of proportionality, the slope is. So we have several you-do problems. So when we determine if the relationship is proportional or non-proportional, we can easily see that we have a y-intercept. So this is non-proportional. And in terms of what is the rate of change, our rate of change in this case is going to be called our slope. And our slope for this equation is 6. For this equation, we have c is equal to 5t. So even though it's not using x and y, it's in the similar form that we've seen it before of y is equal to k times x. And so that makes this equation proportional. And our rate of change, the only number in this equation is going to be 5. So as a review of determining whether tables are proportional or non-proportional, first you have to figure out if it's proportional by using the equation k is equal to y over x. And so you take each point, you divide the y value by the x value and see if they're all the same. If they're all the same, that makes it proportional. If they're not the same, then it makes it non-proportional. So in this case, we have the first point is 5 comma 40, but if we were to write it as y over x, it would be 40 over 5. Our second point is 8 comma 64, but if we were to write it as y over x, we have 64 over 8. And our last point is 11 comma 88. But if we were to write it as y over x, it'd be 88 over 11. And when we divide 40 divided by 5, we get 8. 64 divided by 8 is 8. And 88 divided by 11 is 8. So we can see that they're all equal to each other. So that makes this table proportional. And our rate of change is going to be that 8. Over here, we're going to start by doing the same thing. K is equal to y over x. Our first point is 6 comma 15. So our y value is 17. Our x value is 6. Our second point is 10 comma 25. So our y value is 25. Our x value is 10. The following point is 12 comma 29. So if we do y over x, we have 29 over 12. And if we were to divide 17 divided by 6, 25 divided by 10, and 29 divided by 12, we would see that they are not equal to each other. So that would make this a non-proportional table. And to figure out the rate of change, to find our slope, because we have the equation y is equal to mx plus b, and so m is our rate of change, officially called our slope. We're using the equation m is equal to y2 minus y1 over x2 minus x1. So to figure out what the slope is, I'm going to label some points on the table. So I'm going to say, if I'm choosing the points 6 comma 17, 6 is going to be my x1, 17 is going to be my y1. Then I'm going to choose 10 comma 25 and label 10 my x2 and 25 my y2. Instead of choosing 10 comma 25, I could have chosen 12 comma 29 and labeled that x2, y2. Now I'm going to plug in the numbers. My y2 is the 25. I'm going to subtract that by my y1, which is 17. My x2 is 10. And I'm going to subtract that by my x1, which is 6. 25 minus 17 is 8. And then 10 minus 6 is 4. 8 divided by 4 is 2. Lastly, we have our DOL that's in a Google form. It's the 4 questions. Thank you so much for following along in today's lesson, and see you in the next math video. Bye.